Hello and welcome. In this video, we will be exploring Nmap source code. Nmap is a network mapping and scanning tool. It helps you scan networks and a range of networks based on ports and DNS names or websites name. You can scan those networks, and many of the people watching this video will have some idea of Nmap. It's a network scanning and security tool, and but as I'm not your usual cybersecurity expert, I won't be diving deep into the how to use Nmap in some sense that is useful from the cybersecurity perspective. But we will be diving deep into the source code of Nmap. As you can see here, we have the source code from GitHub of Nmap, and there's so many uh, sites of the same GitHub pages that I have already opened. And we will mainly look at how the Nmap works internally, how it thinks internally, and how it processes the packet sending thing and the packet processing, how it builds the packet from scratch and how it processes them and send it to the host and scan the result that it gets back from the host. So how does all this thing comes and fits together, and how these things work? We will be exploring only that part of the software side of the Nmap in this video. If you want to explore the cybersecurity, I would tell you that this is maybe it will be helpful. This video may be helpful for you to understand how Nmap thinks internally. But if you want to able to use it in different ways, that from the cybersecurity perspective, you should watch YouTube channels that are available on the YouTube, like Network Check. It is a great channel. You should watch it. He uploads some videos on uh, and there is also Dr. Bumble. I don't know. You should, as I said, there are so many great channels where you can learn cybersecurity stuffs. But here we will only be dealing with software side of Nmap, as I mostly that. And in this channel, in future as well, we will be exploring how different softwares work. This video is kind of unplanned and impulsive. So this particular section, the planning of how this thing will move, this exploration and map exploration will move. First, in the first section, I will be exploring the Wikipedia pages and all the documentation and like the overview of Nmap. Then, in the next section, after moving from the exploration, observation, overview, we will be moving to the networking basics, and that will be for not everyone watching this video will need networking basics overview, but for some viewers who are not familiar with how the networks work, how the NIC card works, how the cell towers, and how the network physical, like the backbone of the network works, how the fiber optic cables and the networks communicate with each other, how the protocols work, how are the different OSI layers, like the open system interconnection layers are organized, how the RFC request for comments uh, thing works, and everything that are related to the networking basics. We will be exploring that. It will be very short section, but after that, we will be exploring how the source code uh, we will be exploring the source code, different files regarding the source code, and how makes sense of how Nmap works internally. Okay, so this intro section, I'm recording I'm recording this separately because I have been recording for the past 2 hours, and I believe I thought this video will be over in like 1.5 or 2 hours, but it is taking so much long because I believe the content should be explored more rigorously, because to get the feel of the content, you have to explore it rigorously. So I thought, why not break that this video into a playlist, and it won't be very long playlist. I believe it should be over in two videos of very short lengths, and 2 to 3, maximum to 3 videos will be extending, max to max 3 videos. But I have been exploring in the recording so many, so much as you can see here. We were exploring scan engine. This part of the section of the video you will be seeing in the second part of the second video because I have to record some more regarding the source code. So yeah, I hope you will see how Nmap works, and this will give you an idea of how Nmap works internally and how open source softwares are organized. And best of luck and Happy New Year. As I said, we will be exploring the software side of thing, how the Nmap works, and how the code is written in Nmap, and see how if we can make sense of it. The code is mostly written in C and C++. Lua is used for scripting side of thing. The Nmap is scripting engine, but don't worry about all of that. We will be exploring down the line on this video. But so I haven't planned this video from the start. So we will keep on exploring different things and see how the video takes shape. So one more thing, we will also try to explore some networking kind of basics for the people who don't know already. But I believe most of you guys will already know about networking before you click on this video. And we will also kind of test things in the Nmap scripts. We will try to run it on machines, different IP addresses that I have. I have my Linux machine right on the left-hand side of my table. I would have recorded this session on that machine, but I don't know why the network Nmap is not. What do you say? It's not working. The recording, I can't record it that thing. But don't worry, we have virtual machine, the Ubuntu virtual machine that I'm running on this Windows, and we will try to explore how Nmap works in both of this. If so, don't worry, we will test Nmap. And one more heads up, listen carefully. So, Nmap, you should be scanning your own like machines and things because sometimes I have heard that this you are not permissible to scan some networks like I don't want you guys to be to get you guys in trouble for scanning networks which are not meant to be scanned by normal people, like maybe government sites. I haven't tried it, but you should also you as well should not try it. But so yes, that's it. Do not try scanning networks which are not meant to be scanned. Or if you want to scan them, you can ask the owner of the network if you are permissible to scan the network because it may or may not get you into legal trouble. So yes, so let's begin. And a lot of talking already. Uh, let's begin and look at. I have opened here the Nmap source code, the GitHub source code, and we have the Wikipedia. And let's see what is in there. So first, we will explore as much as we can, then we will move to the networking side of thing. Nmap. So yeah, network discovery and security auditing tool, as I already said. Uh, let's just open Wikipedia. Why we should roam if Wikipedia is available? Yeah, it is. Nmap Network Mapper is a network scanner created by Gordon Leon. Yeah, this guy. He looks Russian, doesn't he? No. Oh, is an American network security expert creator of Nmap and authors of books, websites, and technical papers about network security. He is a founding member of HoneyNet project and vice president. So, in a sense, he is the guy that created this pseudonym for Fyodor. Well, this is Russian. Fyodor Vaskovich. Pseudonym. Yeah. Nmap is used to discover you can think of hosts like the computer or the computing machine that you're trying to scan. You want to see what services are available on those hosts that are hosts. You can look at the definition. I hope it comes. A network host is a computer or other device connected to a computer network. A host may work as a server offering information. Yeah, that's it. The other computing device that you want to scan. Services on a computer network by sending packets. Packets are network packets. You may already know about it, but it's okay. So let's see. Original author Gordon Leon. Doesn't he look like the guy who is the top rank in lead code? No, no, not lead code. What is it called? Code Forces. That guy. And the one who crossed the 3,000 rating kind of thing. Well, but code, let me see. Okay. Mm. Let's stick to the topic. Initial release, it was on 1997, 28 years ago. A very old software stable release. It was on August 2025 repository written in C. Operating system cross-platform, available in English type network security website. Okay. Nmap provides a number of features for probing computer networks, including host discovery and service and operating system detection. So you can host discovery, what ports are open, what services they are providing, what operating system, fingerprinting operating system. These kind of things are done with Nmap. And let's keep reading and see. These features are extensible by scripts that provide more advanced searches, search detection, vulnerability detection, and other features. Nmap can adapt to network condition, including latency and congestion control uh, during a scan. Started as a Linux utility and was ported to other systems, including Windows, macOS, and BSD. Berkeley software distribution. Yeah, it is. Uh, have you guys seen the logo of BSD? Let me show you guys. Uh, Images. What? Whoa, 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 whoa. What is it? BSD operating system. Yeah, look at it. Give it's kind of give the feeling of the what is it called Furiture audio, the time in early 2000 where logos looked like not a plain thing and it looks like a kind of shiny. And let me show you guys few. I hope I am hero hero. It's kind of a design kind of forget your hero. Yeah. See, most of the designs are like shiny and everything. I love this uh, theme of things. Lately, I've been looking at it like so much. I love this. Uh, it was like early 2000 and late 1990s kind of thing. Most of the logos looked like this. They were not scalable. Like when you try to scale this logo, it will kind of like blurry and like the edges will be uh, edgy kind of thing, rugged edges. It was not scalable. The SVG, guys must have heard about it, the scalable vector graphics. So yeah, BSD is has a great logo, kind of nostalgic logo. It is most popular on Linux, followed by Windows. Yeah. Features: faster scan, host discovery, port scanning, ping scan by ICMP, um, TCP/IP stack fingerprinting, and Nmap can provide further information on targets, including reverse DNS name, device types, and MAC addresses. Don't worry about it. If you guys don't know about these terms, we'll explore it. Just give me 10 to 20 minutes. We'll get to it. Typical use of Nmap: auditing the security of a device or firewall by identifying a network connection which can be made to or through it, identifying open ports and target hosts. So identifying open ports and target network inventory, network mapping, yeah, kind of these kind of thing, network mapping, response analysis, and response time measurement. RTT. You guys will see so much of this thing in the code. The response time measurement, response time, like it's abbreviated as RTT, I believe. Finding and exploiting vulnerabilities in a network, DNS queries and subdomain searches. User interface. I have heard and seen the Zenmap. It's the like the UI, beautiful UI of Nmap. Usually, Nmap is meant to be uh, used through a terminal, but and ZenMap is available. So the script kiddie, yeah, meant to be amusing way to format interactive output, replacing letters with a visually like number representative for interesting ports become interesting ports. This is known as leap. Yeah, script kiddie, they love it. They love this tool because I will show you guys one thing, but legal issues. Nmap is a tool that can be used to discover on internet connected system. Like any tool, it could potentially be used for black hat hacking as a precursor or an attempt to gain unauthorized access to computer system. However, Nmap is used by security and system administrators to assess their own network for vulnerabilities. Let's read this paragraph. In its ruling, the Supreme Court stated that the defendant had systematically carried out port scanning operations to gather information for the purpose of unauthorized break into the bank's computer network. This amounted to an attempt to computer break-in. So, as I said, do not scan the networks that you are not authorized to scan. Only scan the Nmap already provide its machine for it to be scanned like for a testing scan. You should just scan that. Why you need to scan all of these things in which you are not authorized to scan? Stay out of legal trouble. That's what I will say. In popular culture, yes, this is what I was referring to. Nmap has been like the mostly like shown in movies, and this is the most shown software in the movies that you can see: the Matrix, Reload, Trinity, and allow the physically break into the building. The appearance of Nmap in the film was widely described on internet forums and hailed as unusually realistic example of hacking. Yeah, the Matrix. The Matrix. I haven't seen this movie, so Matrix fans, should I see this movie? I will see maybe after this video. Nmap, The Listening, Battle Royale, Judge Snowden, Edward Snowden. Yeah, I have seen this movie. Nmap was shown in this movie. You guys should see this movie. It's very great. It's a very great movie to be seen. Here is the usual example. Nmap F. V is, I believe, for verbosity. A is for aggressive, and this. So, if you want to scan any network, scan this. It's scanme.nmap.org. It is meant to be scanned. Okay, it is meant to be scanned. So if you want to try Nmap, and as for me, who is just exploring the software side of thing, this is the best thing to scan. Don't go scan. Okay. So yeah, we will see about it. So from here, we saw that Nmap security scanning, port scanning kind of thing. Let us see the Nmap documentation. Here it is. Do I have two tabs open? Let's close this one. Yeah, this is the logo of Nmap. The, the let's see Nmap book. They also have a book, Gordon Fyodor Leon, from the author, I believe. Let's see. Third party documentation. They have documentation in translated in most of the language, but the English one is original, so we will click on the English one and let's see. Description. What was it doing? Yeah, description and map, network exploration, tool and security, port scanner. This is the grammar. Looks like grammar. And map, you have to pass this argument, the scan type, the options, and the target specification. I believe you should pass the DNS name, DNS for by which the DNS will look up the IP address, and or you should directly pass in the IP address or the range of IP address. Yep. Let's move ahead. As an open source tool for network exploration and security auditing. We have read all of this in OS version, operating system detection, what type of packets, firewalls, filters are used, and dozen of other characteristics, while Nmap is commonly used. We have read this in the Wikipedia, so we won't be reading here. This one. Yeah, the key among the information, interesting port table. The table lists the port number and protocol, services name, and a state. The output of the Nmap sub. Yeah, the output lists all the table of the ports. You can see here. This is a table, kind of looks like a table. The port 22 TCP state open service, which service is running SSH version of the service, open SSH 5.3 P1 Debian Ubuntu protocol 2.0. Yeah, so one more important thing, the state is either the state, you can see here, the state of the port is filtered, closed, or unfiltered, and open. So, four state. The port can be in four state: open, filtered, closed, and unfiltered. So let's go ahead and see what each one of it means. Filtered, that means that a firewall filter. Yeah, the filter is there. Firewall is there blocking the port, so cannot tell. The Nmap the Nmap cannot tell whether it is open or closed. Closed port have no explication listening on them, though they could open up at any time. So the closed port is closed port, unfiltered when they are responsive to Nmap pros, but Nmap cannot determine whether they are open or closed. So you might already know, like open ports are waiting for connection, closed ports are closed but filtered. Nmap, the port responded, the network responded to that packet, to that probe, but the Nmap cannot specify or decide if the port is open or closed. Unfiltered, responsive to the Nmap pros, but Nmap cannot determine whether they are open or closed. Yeah, filtered. So filtered, unfiltered. We These are the two categories, and we have open and closed. These are the things. When an IP protocol scan is requested, Nmap provides information on supported IP protocols rather than listening ports. Okay. SO. We'll explore this uh, parameters. Let's see. Options summary. So we have to scan type options. Okay. Host discovery port scanning. These are the contents available for this reference guide. Operating system detection port, some documentation regarding ports scanning basics, techniques, scan order, service and version detection, operating system detection, and NSE. So these are so like the basic scanning, network scanning is provided by Nmap. And after that, those functions and services are extended through scripts, the script engine. This script is engine that is called Nmap scripting engine. You can script in Lua in it and try to. Nmap already provide like hundreds of script that when you download Nmap, I will show you. I have already downloaded it in my virtual machine. It already provides the list of scripts that you can run. Timing and performance. So when you send a probe and it returns, and what is the timing and performance of that probe, like the round trip timing, those kind of stuff. Output, miscellaneous option, runtime interaction. Okay. Bugs, author, legal. I'm sorry. So legal notice and map copyright and license. These are licensing all stuff. So yes. So why don't we go ahead and try to do a basic scan of this free scan that we can do. Let me open my Ubuntu virtual machine. Here is it lagging or what? What happened? What happened? Should I restart it? Should I? I don't know what is happening. Let's wait for a few seconds. Let me freeze my bottom. Then we will begin with our usual network scan. I don't know. I don't know what is happening with it. Let me just um, let me just stop it. Save a state. Should I? Nah. Let's power off this shit. Yeah. Open start. Normal start. Let's see. I don't know. Why is it doing this? Why? You know what? Let us just for let us just minimize this. What I will do is I have Windows subsystem for Linux. Yeah, open. Let's see. But what? Plug it in. Yeah, let's see. This sometimes this lags the virtual machine. So should I just stop and then connect to the Linux machine via WSL, or should we wait? You know what? We can minimize this, and as we are just trying the Windows subsystem for Linux, what we will do is SSH. We will use secure shell and remotely connect to. Let me see. IP address. IP. Yep. So I don't know if you guys know about secure shell. You can earlier it was telnet where you can like remotely log into remote computers, computing machines, and execute stuffs on there. But today we have secure shell. So the syntax for secure shell is you type SSH and then you enter the name of the computing device and then add the rate and then you will enter the IP address. Usually you do not expose your IP address, but in this case it doesn't matter. In this case, it doesn't matter. I have nothing to hide. 192.168.75 18. Yeah. We would have used the let me just enter the password here. Yeah. Now we are logged into this machine, the Linux machine, via the terminal. And let's see. Now, if you want to install your Nmap on your computing device, the you in case with Ubuntu, you should do sudo apt install and then Nmap. Run this command and it should be okay. Or if you have different operating system, you should just search it on. I have Nmap version 7.94. So let's run this command. What was it? You guys remember? Let's run a simple command. You do not pass the aggressive and the T4. That those are for timing and aggressiveness. But do scan me dot nmap dot org. So as you can see here, it's starting the scan here. Starting nmap will take some time to scan the network. Let's wait and see what nmap has to offer. While it does this, let's just let me show you. Let's just begin with the networking. The one that I promised you earlier, 10 to 15 minutes earlier. So yeah, I have this whiteboard open. Let's reconnect. Do we have a better picture? Yeah, but copy image. We have the satellite here. No, We messed up. Just a second, guys. Just a second. Please bear with me. It will take a few seconds. Yeah. And let's move this our computing device here. Let's just erase all of this. And also, let's move this here. So, all of the system is placed so that your computing device can talk to another device on the network, and you can share all the files from one device to another device. You can use Instagram to share your videos, your short videos. You can use YouTube to share information like we are doing. So that's why the sharing of information doesn't happen magically. It has a system that is already exist via a lot of engineering efforts. That we have the cell towers, we have the satellites, we have the servers, we have the optical cable that runs under the ocean. All of these things helps to communicate from one device to another device. Now let's dive a little bit deeper. What happens? Why we need protocols? This so now earlier you were only worrying about two systems, two computing device uh, understanding each other. Now you have a range of devices trying to understand each other. You have the cell tower trying to understand the satellite data. You have the satellite data trying to understand the data that is coming from the server. You have the uh, server like it is storing data in kind of electrical uh, electricity, and the fiber optic cables, it's transferring data in kind of light wavelength kind of thing. You need to make all of these machines understand each other to transfer the information. Like if the system A is typing ABC and the system B, you have to ensure that system B does not see like if you type ABC, and what happens if he sees BCD? You understanding me? Like you want to keep the information intact when you are transferring one information from one system to another. So you have to make sure that every uh, entity that is used to transfer that information from the other system needs to understand each other clearly and efficiently so that no information is lost or mismanaged. How do we ensure that? So that no information is messed with in while transferring. You have to have protocols. That's why you hear the TCP protocol, the IP protocol. What are those? Let's say to make the system, to all of the systems trying to uh, communicate with each other, understand each other, you have some system placed here. The TCP protocols, the IP protocols, Internet protocol. Oh my God. The FTP protocol. You have all this protocol so that you are ensuring that one system. These are kind of, you can think of them like laws. How do so? Let's dive a little bit deeper. I'm trying to show you guys one more thing. So, what happens if one application you're trying to send information to, it usually goes through your system to through the NIC card, the network interface card. What it does is, let me have a photo of this. So this is the device you must have to talk to the internet. What it does is, here you can see the cable. You connect it to the internet. It converts those packets that are saying converts those bits and signals that it is receiving into small fragments of packets, and then pass it to the upper layers of the networking stack to make the sense of those data. So Suppose the fiber optic cable is sending lights, blinking lights. Essentially, those are blinking lights and of different wavelengths. It comes through this NIC card makes sense of those data and transfer it to your computer. Same, vice versa. It takes data from your computer, convert it into signals that can be transferred via these cables. So it is kind of, you can think of it like an interface between your electronic data that you're trying to send or communicate and the fiber optic data. These two systems, like you cannot combine like wavelengths into electronic signals. Or what is, I think I'm mispronouncing these words. Uh, like network packets, though that exist in bits, and you have to convert them into wavelengths. You to make sure those data stay intact, you have to have the system, and that system, one of the example of those system is the NIC card. I hope I'm making things clear here. So to make your bits and bytes compatible with the optical fiber signals, you have your computer uses the NIC card. That's the simplest definition that I'm able to come up with. Okay, so what happens? Okay, then the Wi-Fi or the communication signal. If you are making a phone call and your device sends that data, converts that data using some electronic device to wavelengths, the signal to communicate with cell towers. You understand? And how the cell towers picks up this signal? Let me show. There is cell tower 3D triangulation, some kind of thing. Like, let me search using this alpha, beta, gamma, and cell tower. If you're making phone calls, images. So yeah, this is the thing. So your cell tower center. So let me find a better picture. I'm trying to I believe this one makes sense a little bit. Yeah. So whenever you call or video call or something and your device is trying to connect via network, it connects through a cell tower first. And the cell tower, the areas of the cell tower is divided into three cells, towers with three cells, each with 120-degree angles. So if you are in this area, the cell tower will communicate with this your device through this area. Like partitioning available devices into each sections. And like how this cell towers work is the cells, your geographical area is like divided into each cells in a kind of a honeycomb way. And you have devices in each cell trying to communicate with the cell tower. Cell, geographic cell, geographic. Let me search it. Cells, cell tower. I hope there is a picture. So, like a section is uh, geographical location is divided into cells, and each cell has their yeah. There you go. So cell tower. So each cell, the hexagonal cells, I believe this is called a hexagon. So each cell has its own cell tower. And suppose if you're in a car on it or a train and you're making a phone call or a video call to your loved ones, and you are moving from one cell to another, there while moving, it's a signal handoff kind of thing. I believe it's called signal handoff. So your data, like the transferring interconnection through which you are transferring your data is transferred, handed off from one cell tower to another cell tower to help your device communicate with the network. So these are the things. I believe I'm getting in too much depth. So yeah, so once the cell tower, once your signal reaches the cell tower, it's transferred down the lane through the optical fiber. There you have optical fiber in the cell towers, like in the base of the cell towers, I believe, and those are transferred to your internet service provider, and then you have the Internet of Things that are transferring your signals in an intact thing. Using all those things like I don't know if you guys have heard about hubs, repeater, and signal processing, all of these devices you can see in your towers outside of your home. These are used to transfer the signals intact from one place to another to help your device communicate with the other device. The other device will also have here the NIC card of itself. Here you go, the NIC card. So like I said, can we like rotate it? No. Yeah, here. So here are your signals, the bits. Now the operating system will transfer those bits into here, these pins, and these and this NSA card will convert that into optical signals. And again, your signal using all this network physical infrastructure, your signal will reach the NIC card on the different device. It will receive those signals and convert it into bits, transfer it to your operating system, and your operating system will make sure that information is displayed on your what happened displayed on your screen. So that's how the network thing works. Your two devices communicating. I hope I'm making sense here. So physical. So you have the OSI model, the open system interconnection model. You have the application layer. So your application, like Chrome application or other different applications that you are using, they reside in the application layer. Now, if you want to transfer anything between the two computing device, your information is transferred via these layers to the physical layer, the media, signal, and the binary transmission. And on the other device, it usually goes from the physical device and transfer that data to the application level. And to make these levels communicate with each other, you have the protocols, different protocols. Like, let me give you an example, if I can come up with one. Also the NIC card is like it has a bird in like the physically it is like written on the NIC card, your MAC address of your computing device. Then you have the IP address, the MAC address and IP address. The IP header, we'll explore that in the Nmap source code. Don't worry about it. The IP address and the transport layer, the session layer, presentation layer. You know what? When we will look at the source code, this all will make sense. I don't know. I should have planned the video before starting this. I'm regretting this, my decisions. Sure. So, yeah, let's see. I should have, I'm thinking I should have arranged the photos earlier. So this is the basic way that one device communicate with another device. You have a different system placed to like inter-process communication. You have different applications running on the same device, and they want to share information. You have a system placed to do that, and that process is called inter-process communication. So communicating two processes in one device, inter-process communication, and these inter-process communication, like one device to another device. You have two devices communicating. Well, you cannot teach in the whole networking thing in one like 20-minute section. You need more time to it. So that's also the thing. We'll sometime cover this in detail, but you know what? You have the protocols that we will see in the source code. The so you don't worry about it. And let's see. You have now you by seeing this, after seeing this, you have the basic idea, like the feel. You have to feel the network transferring one information, one from one device to another device. You have to feel that. I believe this will give you that, maybe, or you can watch any video, whatever you want. So let's see. And we were also, what happened? Yeah, we were also scanning the Nmap. So you can pass in the Nmap to run the script, run the program, and then we passed the address of the machine without any options and without any parameters. And let's see what it did. Starting Nmap 7.94 version SVN, and the Nmap scan report for scanme.nmap.org. Host is up, and this latency other address for not scanned this our address not shown 996 closed TCP ports. And this is the port table that the documentation was talking about. We have 22. This is a number of the port, and the port 80, port 9929, and all of these four ports are open in that machine. And these are the services: SSH, HTTP, and Ping Echo Elite. These are the services that are running on this board. So this is how you run the basic nmap command. Let's go ahead and see the source code, how it does. Yeah, so I believe I will have to stop this video right here because uh, as we have already covered the overview exploration regarding the Wikipedia pages and the documentation, and all those overview, and we have ran Nmap like the usual very basic way regarding the usual scan that is provided for test in Nmap. We will explore further regarding the tests, and we have also explored some of the basics of networking. I believe some part of it is still missing. I believe regarding the protocols, and we also have remaining. We also didn't explore regarding the RFC, request for comments, where the like the protocols are deeply mentioned and described, like the RFC for TCP. Let me just show you guys RFC, like the 90. Let me see, is this one? Is this the one? I believe so. Yeah, for address, location, and private. These are the official documentation regarding the RFC. We are also remaining with these kind of thing regarding the TCP and somewhat IP and all of this RFCs. We will explore a little part of this in the second video, and also the third section of the video where I said we'll explore the code and how the Nmap thinks internally. Half of that part is already recorded, but there's still some parts regarding the uh, NSC engine, the Nmap scripting engine, and some scan engine code. We have to record. I have to record that as well, but this video was kind of unplanned, so it is taking so long that I've decided to stop the recording here, as it already, I think, 1 hour of video. Next video will be around this much length, but that will be the final video, I believe, and we will cover everything regarding the source code and the RFC comments in the second part of the video. And we will try to explore Nmap more deeply in the second part. Um, that's all. So, see you guys in the second part of the video. Bye bye.